Assalamualaikum. So, for our group, this project investigates how feature selection and feature extraction affect the performance of a backpropagation neural network on the high dimensional communities and crime dataset. So, we use recursive feature elimination RFE and principal component analysis PCA. So the study compares model accuracy to identify which approach better reduces dimensionality while maintaining predictive performance. So this is the dataset that we use, communities and crime dataset, which contains a wide range of information describing different aspects of US communities. So it includes socioeconomic attributes such as population, household size, race, the median income. So altogether there are 147 attributes, which uh, most of them are numeric and represent percentage or rates. So the target variable, which is violent crimes per population, indicates the rate of violent crimes in each community. So each community is this column right here. So this represent violent crimes in each community. So this mix of social and crime-related data allow us to explore how community characteristics relate to crime levels.
Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, now I will continue with our feature selections. Okay, so for our feature selection, we choose a wrapper method, which is a recursive feature elimination in our datasets. So, firstly, we will apply and train a model, which is we choose a SVM, which is a supports vector machines in these features. And next, we ranking the features by coefficients that's assigned by the SVC. And after that, we remove the unimportant and unnecessary things from the features. And lastly, we repeatedly this process until we got the best results. So Alhamdulillah, after we complete this task, we managed to reduce the features from 141 until 20 features. So that's that for me. Thank you. Okay, now we will move to the next step. So for the next step, we will rerun the feature selection with the recursive feature elimination with the new data, which is the result of the previous step. So after we rerun it, we will evaluate the performance of the model to be run. And Alhamdulillah, we got the testing accuracy with 93.53%, and we got the confusion metrics to be analyzed. That's that from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Bashar bin Kamarul Anwar. Now I'm going to present about PCA. So as you guys know, we have a very large dataset with 141 features or columns. Okay, so we want to reduce the columns used. So for our second model, we use RFE. PCA is different than RFE. RFE is selecting the best features out of all the 141 features. You select the features that you think will explain the original features best. But for PCA, we are not going to eliminate anything. We are going to use all of the columns, but we are going to combine them. We are going to combine them to a new abstract features and less than the original features. So before, we use feature selection, but now we are using basically feature extraction. Okay, so how do we do that? So the first question is how many columns that we are going to need. Okay, so to do that, we are going to run this cell. Okay, so this is PCA. This line basically says, okay, now create PCA tool. Okay, now that you have created PCA tool, now use that PCA tool and feed it or applied it to your train dataset. So after you have applied it to your dataset, then generate all of the variants for every single super feature. Super feature is a new feature that you have generated from the original features. Okay, so now generate the variance. What is variance? Variance is how much is this new super feature relate to the original features. Okay, so we don't know yet how much components that we need. Okay, so now we run this PCA final, PCA and components. This will generate how much components that we need with 0.95 threshold. So using the algorithm, it says that we need 47 features to achieve 95% variance. Okay, so now we have reduced our features from 141 to 47. So what we do here is, now we know that we need 47. Now we actually apply, we make a new variable that stores these new 47 super features, right? So after we do that, now we have to try backpropagation again with the new 47 super features that we have extracted, right? So in this code is basically you just backpropagate again and evaluate the performance. Okay, so the results will be stored in this, and the accuracy that we get is 87.67%, which is less than the baseline model and also less than the feature selection or the RFE model. Why? I will leave that for my team member. That's all for me. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Amin, and today I'm going to present for the evaluation of performance of our model. So, first of all, as we can see from this output, this scatter plot gives us a visual representation of those results. The horizontal axis represents each of the 665 samples in our test set. The vertical axis shows the two distinct clusters, which is low crime and high crime at the top. The blue dots represent the actual cluster, while the red dots represent what our model has predicted. Alright, as you can see, for both the low crime and high crime bands, the red dots and the blue dots overlap almost perfectly. The few instances where you see a lone red or blue dot represent the specified total misclassification, which is shown in the coefficient matrix. And I will show you the coefficient matrix after this. Alright, so let's begin looking at the performance of our baseline model. Wait, right here. Alright. So this is our propagation neural network trend or the full original dataset of 141 features. No feature selection or feature extraction has been applied yet. The goal here is to establish a benchmark starting point to measure all our auto optimizations against. So as you can see here, the model correctly predict 332 low crime and falsely predict 31 low crime. And for the high crime, there are a total of 34 that have been falsely predicted. Meanwhile, the high crime predict correctly with a total of 268. And this baseline has achieved accuracy of 90.23%. Alright, so moving on to our first optimization, we apply feature selection to see if we could improve performance and efficiency. So right here, for this, we use recursive feature elimination, which is a method that repeatedly builds a model and removes the weakest features. Our goal was to find the top 20 features out of the original 151. We then trained a new backpropagation model using only these 30 most impactful features. So as you can see here, the total of log frame that we predict correctly are higher than our baseline. But meanwhile, it predict false incorrectly with a total of 30, which is less than our baseline, with a difference of 1. Same goes for the high crime, which is correctly predict higher than our baseline, and it predict incorrectly but lesser than our baseline. So it achieved the accuracy with a total of 93.53%, which is higher than our baseline. Because this is because by reducing our feature set from 151 down to just 20, we didn't just maintain our performance, we significantly improved it. The RFE method successfully eliminated the noise from the dataset, allowing the model to make more accurate and reliable predictions. Alright, so this is a clear win. Now let's see our final method, feature extraction using PCA. Alright, so our final experiment involves feature extraction using principal component analysis or PCA. Unlike feature selection, we choose the best features AI PCA transform all 151 original features into a new small set of principal components. These components are brand new features that capture the most variance or information from the original data. So as you can see here, it actually a lot worse uh, than these two baseline and the baseline feature selection. Well, as for example, the model currently predict 330, which is less than our baseline and our feature selection. So same goes rest of them, which is totally less accurate than our previous two model. As we can see here, the model achieved test accuracy of 87.67%, which is lesser than previous two model. Based on our analysis, we determined that we need 47 uh, principal components to retain 95% of the original data variant. We then train our PP model on this new 47 component dataset. While PCA is incredibly powerful technique for reducing dimensionality, in this specific case, it was less effective than feature selection. By compressing the 151 features down to 47 components, we successfully reduced data, but we also lost some of the key predictive information along the way. This led to less accurate model. So in conclusion, reducing our features from the 141 down to the top 20 using RFD, we not only create a faster but more efficient model, and it also boosts its accuracy to a height of 93.53%. So that's all from me.
So, in conclusion, this project showed that feature selection using RFE performed much better than the feature extraction using PCA for this dataset. So the RFE improved the neural network's accuracy to 93.53% by focusing on the most relevant features, while PCA reduced the performance to 87.67% due to information loss. This highlights that the right feature engineering method depends on the data set and the specific task. So there is no single best approach for all problems. Thank you.